The next stage in creating our enemy is to create the enemy shooting script to control all the aspects of the enemies firing their guns. Before we make the script, we need to give the robot a gun. The model we need is in the Models folder and is called Prop Sci-Fi Gun Low. Drill down into the hierarchy of the robot guard until you find his right hand. Then zoom with the scene view until you can see it. Now drag the gun model from the project panel and drop it onto the hand as a child object. We need to position this gun so that it is in the right position for when the enemy is walking and shooting. We're using a position of 0.1, 0.021 and -0.02 and a rotation of 332, 101.4 and 263.8. These settings will compensate for the position of the enemy's hand when animated normally. Next, we need to make some effects for when the gun is fired. Create a new game object and call it fx_lasershot, and then make it a child of the gun. Now we can tweak the position of this game object so that it's at the end of the gun. We'll start by resetting it, and then move the position to 0, 0.05, 0.2. Now we are going to add a point light and a line renderer. These will be triggered when the gun is fired. To add the light, click Add Component, Rendering, Light. The default type is a point light, which is what we want. To add the line renderer, click Add Component, Effects, Line Renderer. A line renderer creates a simple flat mesh that connects two or more points with a material drawn onto it. It is ideal for drawing effects like lasers, as we will be. You might notice that by adding a line renderer, we now have a pink square at the origin. This is because the line renderer currently has no material. To fix this, search for the material called fx_lasershot in the project panel and then drag it on. Also, in order to give our laser a bit of a tapered effect, we are going to change the width to 0.05 at the start and 0.025 at the end. You can find these settings under the Parameters section of the component. The point light will mostly be controlled by code, but we will turn the intensity down to 0 to start so that it doesn't interfere with the lighting in the scene. We now want to write a script for controlling all the aspects of the enemy shooting. Close the enemy's hierarchy and select the parent object now. Add a script called Enemy Shooting, then open it and prepare it as usual. We are going to make the damage done to the player scale with proximity. The closer the enemy is, the more damage it does when shooting the player. With that in mind, there are a few public class variables that we need to set up. Firstly, we need two floats representing the maximum and minimum damage per shot. The player has 100 health to start with, and if close enough, a single shot should kill the player. That said, the player should not have to be right next to the enemy in order to die from a single shot. So we will give the maximum damage a default of 120. The minimum damage of each shot should still be significant, since we want to encourage stealth in this game. Let's give it a default of 45. Next, we will need an audio clip to be played with each shot. We are using a point light to help simulate the shot. We need an intensity for the light as the gun fires and a speed at which the flash should diminish. In addition to those, we have a few private class variables that we will need. We will need a reference to the animator component. Since we're referencing the animator, we will need a reference to the #ID script. We have a line renderer and a light for effects that we will need references to. To give the enemy a distance range for firing, we will use the radius of the sphere collider, so we will need a reference to that as well. We need to know the player's position, so we will need a reference to its transform. The last reference we need is to the player health script, so that we can call the take damage function. Aside from these references, we will also need a Boolean variable to determine whether or not the enemy is currently shooting. And finally, we are going to use a float to store the amount of damage that is scaled. This will be the difference between the maximum and minimum damage. This is not essential, but it is slightly neater and makes the code easier to read. Now that that's done, let's assign our references in the awake function as normal. To find the line renderer, we are using a function called getComponentInChildren. This returns a component of the given type, but looks on a game object and all of its child game objects to find it. It is worth noting that since the lasershot light and lasershot line are on the same game object, and we already have a reference to the line, we can use the game object it's attached to get the reference to the light. We use a similar principle to find player health once we have the player transform. The next commands that we need to add to Awake are to make sure that by default, the lasershot line is disabled and the lasershot light's intensity is 0. Lastly, we will need to set scaled damage to the difference between the maximum damage and the minimum damage. Next, we will look at the update function. In update, we need to check the current value of the shot curve that we used in the enemy's animator controller, so we will store it as a float here. Remember that the enemy's shoot animation features a curve which begins at 0, peaks in value when the weapon is fired, and then quickly returns to 0. We can use the value from this to time our effects. Now that we have stored the value of this curve, we need to check if it is peaking. If it is above 0.5, then we can assume that it's peaking. However, we only want to shoot once, so we make sure that it's not already shooting when we first detect that the curve is peaking. Next, we are going to create our empty shoot function, so that we can put a call to it here. The shoot function should be called once per shot. We will come back to complete this function shortly. Next, we need to check if the curve is not peaking. And if it is not, then we know the enemy is not shooting. We should also turn off the line renderer so that it's not displayed when the enemy is not shooting. The last thing we need to do in our update is to fade out the flash of light when the enemy shoots. To do that, we will use a lerp to fade the intensity of our laser shot light between itself and 0. Now we can move on to the shoot function. The first thing we need to do in this function is to say that we are shooting. The maximum distance at which the enemy can shoot the player is the radius of his sphere collider. This is because when the player is beyond this distance, he is no longer in sight. With this in mind, the next thing we need to do is to calculate the distance of the player from the enemy as a fraction of the sphere collider's radius. This should be a number that equals 1 when the distance from the enemy to the player is 0, and when the player is at the edge of the collider, the maximum range, the number should equal 0. This is calculated by finding the difference between the collider's radius and the distance from the enemy to the player, and dividing by the collider's radius. Next, we need to calculate the damage that the player will take, that is, the amount of damage to be scaled multiplied by the fractional distance plus the minimum damage. Now we can call the takeDamage function from the player health script and pass in the amount of damage we have calculated. Finally, we will need to display the visual effects of the shot, but instead of putting that here, we will put it into a separate function called shotEffects and call it here. First, we need to set the start position of the line renderer to be at the end of the gun, which is already the position of our fx_lasershot game object, and we need to set the end position to be where the player is. We do this using the setPosition function. The first parameter is an integer representing the point of the line, 0 being the first point, 1 being the second, etc. The second parameter is a vector 3 representing the position in world space of where the point should be. Instead of using only the player's position here, we are adding the value of vector3.up times 1.5. This is because the player's position is at the model's feet, so we need to add some height so that the enemy shoots at his abdomen instead. Next, we need to turn the lasershot line on by enabling the component. We need to set the intensity of the lasershot light to the flash intensity. Finally, we need to play the shot clip at the position of the lasershot. Now we can put a call to the shot effects function inside our shoot function. Before we are finished with this script, we need to make the enemy point the gun at the player when he's shooting. We're going to do this by using inverse kinematics, which is dealt with in the onAnimatorIK function. We will define it just below the update function. The first thing we want to do in this function is to store the value of the aim weight curve that is on the raise, shoot, and lower weapon animations. Next, we want to set the IK position using the setIKPosition function of the animator. The first parameter of this function is an enumeration called avatarIKGoal. An enumeration is a collection of named constants, and the one we will be using will be the right hand. The second parameter is the position that the right hand should be aiming at. We will be using the player's position plus 1.5 units up. Again, this is because the player's transform is at his feet, so in order to hit him around the center, we need to aim up slightly. Lastly, we need to set the weight for the IK. We do this using setIKPositionWeight. Again, the first parameter is an avatarIKGoal to say where we're applying the weight, so we will use the right hand enumeration again. The second parameter is the weight, which we stored earlier as the aim weight. That's the end of our script, so we can save it now and return to the editor. We'll reselect the char robot guard, and on the shot clip, open the audio folder and drag on weapon sci-fi gun fire. Also remember that because we created this script directly on the object, it will currently be in the root of assets. So drag and drop this into our scripts enemy folder. Then you can save the scene and save the project. In the next and final assignment, we will be going through making the enemy AI script, the brain of the robot guards.